Welcome to the October issue of the American Journal of Physiology's Heart and Circulatory Physiologies from the editor's desk. I hope you had a chance to take a look at the October table of contents. It's chock full of great science, including 4 great review articles. So let's take a peek inside. Alibi et al. Discussed the role of extracellular vesicles in cardiac repair. The review covers a very exciting and hot area of investigation and therapeutics. Cellular therapy has received significant attention as a therapeutic approach to restore cardiac function after myocardial infarction. Extracellular vesicles regulate cellular function through the transfer of cargo such as microRNAs and proteins, which act on multiple biological pathways within recipient cells. The authors also discussed the emerging use of extracellular vesicles for rejuvenation-based therapies. Finally, future directions for the use of extracellular vesicles as therapeutic agents for cardiac regenerative medicine are discussed. Kyle and Ceslik review the cardiac fibroblasts as it pertains to aging. Dysregulated cardiac fibroblasts have a reduced capacity to activate a canonical transforming growth factor B SMAD pathway and differentiate poorly into contractile myofibroblasts. That results in the formation of an insufficient scar after myocardial infarction. In contrast, in the uninjured aged heart, fibroblasts are activated and acquire a profibrotic phenotype that leads to interstitial fibrosis, ventricular stiffness, and diastolic dysfunction, all conditions that may lead to heart failure. Aryan Singay et al. Review novel methodology to examine extracellular matrix remodeling. Here they highlight the most prominent characteristics of extracellular matrix remodeling in cardiovascular disease and describe how these features can be mimicked with synthetic and natural biomaterials that offer independent control over multiple extracellular matrix related parameters such as rigidity and composition. They detail innovative microfabrication techniques that enable precise regulation of cellular architecture in 2 and 3 dimensions. Review by Davel and colleagues. There is a nice summary of the role of aldosterone and mineralocorticoid receptors in cardiovascular disease and sex-specific effects. This review, based on a symposium at the 2017 IUPS in Rio de Janeiro, how mineralocorticoid receptors expressed in endothelial, vascular, smooth muscle, and immune cells plays a critical role in the development of vascular disease associated with aging, obesity, and chronic aldosterone stimulation, and demonstrates that mineralocorticoid receptor antagonism prevents the acute renal dysfunction and tubular injury induced by ischemia reperfusion injury. In the 4th review in this issue, Al-Mohana and Ray discuss hypoxic preconditioning of vascular and visceral smooth muscles. They consider the role of blood vessels in conditioning and explore evidence for conditioning in other smooth muscles. They distinguish effects on myocytes from other cell types in the visceral organs. They suggest what may be general mechanisms of conditioning occurring in all smooth muscle cells and tabulate tissue-specific mechanistic findings and suggest ideas for further progress. Kim et al. Hypothesized that piezo-1, a recently discovered cation channel, may be involved in the process of shear stress mechanotransduction, as other studies have shown that it is both mechanosensitive and linked to NO production. Immunohistochemistry confirmed that piezo-1 is present in uterine arteries, primarily, but not exclusively in endothelial cells. Western blot analysis showed that its protein expression was elevated during gestation. In pressurized main uterine arteries, pharmacological activation of piezo-1 by IOTA-1 produced near maximal vasodilation and was associated with significant increases in intracellular calcium concentration in endothelial cell sheets. Shear stress induced by intramural flow produced a reversible vasodilation that was inhibited by greater than 50% by GSMTX4, a piezo-1 inhibitor, and by N-nitro-L-arginine methylester inhibitors of nitric oxide synthase. Jaiji et al. Assessed whether elevated afterload reduces right ventricular contractile reserve despite compensated resting function using non-invasive exercise imaging. 14 patients with pulmonary artery hypertension and 34 healthy subjects completed real-time cardiac magnetic resonance imaging during submaximal exercise breathing room air. Control subjects were then also exercised during acute normobaric hypoxia. Right ventricular contractile reserve was assessed by the effect of exercise during hypoxia, but the response of left ventricular ejection fraction to exercise did not change. In control subjects, the increase in stroke volume index on exercise was driven by reduced RV and systolic volume, whereas patients with pulmonary hypertension did not augment the stroke volume index, with increases in both end diastolic and end systolic volumes. The authors conclude that non-invasive cardiac imaging during exercise unmasks depleted right ventricular contractile reserves in healthy adults under hypoxic conditions and patients with pulmonary artery hypertension under normoxic conditions, despite preserved ejection fraction at rest. Thank you for watching this month. Please spread the word to your students, fellows, and colleagues to tune in as often as possible. From all of the staff at AJP Heart and Circulatory Physiology, have a good month and enjoy Halloween. See you in November.